don't, as long as you just, if you're like, pay attention, which I don't.
Yeah, we know you don't pay attention. Okay, so we're going to do arithmetic sequences and partial sums. Hopefully today will be easy. I mean, we do this last because I don't really think this stuff is very difficult for you at all to begin with. The worst part is I'm going to make you memorize a couple formulas. It shouldn't be too bad. Okay, definition of arithmetic sequence is a sequence where you add the same number every time. So, the even numbers. Yeah.
I want to ask, what is 2 times infinity? Would that just be infinity?
Infinity's not it's not a real number. It doesn't exist.
Really?
Yeah.
Isn't it just a placeholder?
Okay, so this is an arithmetic sequence because you add the same number every time. Okay, guys. Manny. It's enough. Okay, so that's the definition of arithmetic sequence. This thing that you add each time, it's called the common difference. It's called the common difference because if you take any 2 terms and you subtract them, you'll get that. So, if I take 10 minus 8, I get that too. Our book always uses D to represent that. So again, if I take any 2 consecutive terms, so if I take an minus 1, I will always get that D. So that's the definition of arithmetic sequence. And arithmetic sequence, a nice thing about them is they're always linear. So I have a nice formula for it. And that's considered the linear form. It's linear form because, that's the same equation for a line. You just put a y in for an and an x in for, or an x in for the n, and you have y equals mx plus b, pretty much. Come on, Manny.
Yeah.
Settle.
Got
Sit at that end, and it's big.
Manny, just sit like where you normally sit.
Yeah, no, I just gotta write down the definition first.
Okay, we have another form that will actually help us a lot more. That one will help us out as far as writing the equations. Because a huge part of what we're going to be doing is writing equations for this. That one will help us out more than the linear form. The problem with the linear form is the c. You have to calculate the c. If you use this form, you don't have to calculate anything. And then if they ask for linear form, then you just solve this. You just simplify this side, and then you have linear form. Okay, you good with that? Can I switch pages? All right, so anytime they're asking you for the nth term of a sequence, that means they just want you to write the formula. Unless they specify what kind of formula you're supposed to write, again, that is going to be the easiest one for you to write. Use fill in A1. A1's your first term. So what's our first term? 3. And D is your common difference. That's what you add each time. So what are we adding each time? 4. There's my formula. That's it. Nope. Not unless they ask you to. They ask for a formula, there's a formula. So the time whenever you would want to simplify is like an example 2. If they ask you for linear form, then you would want to simplify. But I would still just go ahead and start it the same way. Oops. I don't want a 3 there. So my first term is 20. And then what am I adding each time? -6. And then since they want linear form, then you would go ahead and simplify. And then example 3 is supposed to be the hard one. Again, nice thing is, pretty much all this section is plugging in numbers into formulas. You just have to, the hard thing I'm going to make you do is you have to remember the formulas. Okay, so write the first 5 terms of a sequence where the 6th term is 14 and the 15th term is 41. So this is what I know. I know that A6 is 14 and A15 is 41. So, since it's arithmetic, which I should have written that in there in the instructions, but we're just assuming everything in this section is arithmetic. I know this. To get from A6 to A15, I need to add my common difference 9 times, right? So I would take, and add my common difference to get to A7. Then I'd add it again to get to A8. Add it again to get to A9. And I keep doing that till I get to A15. Well, that's going to be 9 times. Yes, sorry. There you go. That's right. Okay, so now I can calculate what D is because I know what those two terms are. This one is 41, and this one is 14. Oops, it's supposed to be a plus sign. So I can calculate what D is. So let's see, 41 minus 14, 27. So D is 3. So since I know what the sixth term is, what's the fifth term? 11. So the fourth term?
How can you tell those numbers?
It's since the common difference is 3, that means the number that I add each time, right? Well, since the sixth term is 14, I can go backwards by subtracting. So since the sixth term is 14, that means the fifth term is 14 minus 3, which would be 11. Then I subtract 3 again to go backwards to the fourth term. Subtract 3 again to get to the third term. Subtract 3, subtract 3. So then here's my first 5 terms that they were asking for. I could also figure it out if they didn't give me something quite that nice. I could also figure it out by using my formula. A6 equals A1 plus 6 minus 1 times D, which is 3. And that's using this formula here.
When is our test going to be?
Oops, D. Tuesday.
Oh. Is it going to take a while?
No. Because that's going to be your finals time. So then you know that A6 is 14. See, that would, dang it. So that would also tell you, so you know if A6 was way too far just to count backwards, you could also calculate it that way. So there's your difficult kind of problem. Okay. All right, we have a recursive definition. Recursive definition isn't very helpful, but your book gave it to you. It actually comes from the definition of D. Remember, definition of D was AN minus AN minus 1, right? So our recursive definition is just AN equals AN minus 1 plus D. We just add that over to the other side. Which is really what you do all the time, right? If you know a term, to get the next term, you just add on whatever your common difference is. Again, not very helpful. It's kind of your definition of an arithmetic sequence as it is. Okay, what is helpful is the sum of a finite arithmetic sequence. That is very helpful. So what we're talking about is like down here. If I have an arithmetic sequence, so this is just the odd numbers. So what if I want to add up all the odd numbers from 1 to 31?
Add
Yep, that's your formula. So, your formula, you take how many you have divided by 2 times the first one and the last one. Wait, that's, yeah. So that's a useful formula. So instead of going through and adding up all these numbers, all I have to do is take 1 plus 31 and take that times, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So 16 divided by 2. So 32 divided by 8. Or 32 times 8, sorry. 200 what? So, if you add up all the odd numbers, 1 through 31, you get 256. So, to make this a little bit more complicated, what if you wanted to add up all the numbers 1 to 100? Because that's an arithmetic sequence, because you're adding 1 each time. So you take 100, divide by 2, because you have 100 numbers there. So you have 50 times 101. So see? Nice. All you have to do is plug in numbers. I have 2 more examples, but again, all we're doing is using that formula. Okay, so these are, I guess I have 3 more examples. These are a couple more ways that you're going to be presented this. So if they give you an arithmetic sequence and they ask you to find the 120th partial sum. The problem with this one is we don't know what the 120th number is. Yep. So you have to use the first formula. Let's see, my common difference on this is 3. So you use the first formula to create a formula for your sequence. Then I can find the 120th term by plugging in 120. So 119 times 3 plus 7. I don't have a calculator. 364. So then this is 371 times 60. What was it? All right, now they can present the same thing, but they can present it in summation notation. The way you know that it's arithmetic is, again, your equation inside here is linear. So as long as they give you a linear equation inside here, then you can use our formula that we just had. We have to calculate our first term and our last term. So our first term would be plugging in 1. So that'd be 5 minus 1, so that'd be 4. And our last term would be plugging in 64. So let's see, that'd be 320 minus 1, so 319. So 32 times 323. Yeah, I'm not doing that one. What? 326? 36. Oh, okay. Start all over. 10,000.
336.
Okay, one more. So what if it doesn't start at 1? Because it's nice if it starts at 1, because then you know exactly how many numbers you have. Well, no, your first term is still going to be if you plug in 10. So if I plug in 10, my first term is going to be 23, because that's still where I'm starting, my sum. My last term is still going to be 103. The problem is n. How many terms do I have? Yeah, you're right. 41. So you have to be careful. You can't just take 50 minus 10 and get 40, because that's not correct. Because like if I come up here and I take 64 minus 1, I actually get 63. So that's normally, that's what I see people want to do. They want to subtract, but if you subtract, you leave off your first thing that you did. So if you want to subtract, that's fine, but always add 1 on. But if you're counting, you always start with that first number. So I guess that would be the easiest way to think of it is you can subtract them, but then you have to add on that first number again. So this time I have 20.5 times 126. 2,583. Yeah, it doesn't matter. It's all just arithmetic. If you want to, you could take that 2 and divide it into that and make that 63. That's fine. Okay, so that's it. Is any of this stuff familiar to you guys?
Yes.
Yeah.
Okay, so you've at least seen it before, and this is just kind of
Yeah.